Hypersensitivity is a condition where our immune system is being overprotective that's led to harmful effects due to aggressive response to antigen that pose little or no threat. Hypersensitivity can be classed into several types.
Type 1 hypersensitivity reaction are initiated by IgE and multivalent antigen. IgE will bind to Fc receptor on the surface of mast cells, basophils, and eosinophil, cross-linked by allergen, resulting in rapid cellular degranulation and release of inflammatory mediators. The early phase of type 1 hypersensitivity reaction can occur within minutes of allergen exposure. The reaction can be localized or systemic. The cross-linking of IgE to receptors is known as sensitization, resulting in the release of chemical mediators which cause vasodilation, increased vascular permeability, and functional change in affected organs. The late phase reaction typically develops around 2 to 9 hours after allergen exposure. The mediators released from the reaction will induce the localized inflammation.
Type 2 hypersensitivity involved antibody-mediated destruction of healthy cells. This disorder tends to be tissue or organ specific. During immunotolerance, some self-reactive immune cells escape and attack the healthy cell and cause autoimmune disease. In cytotoxic type 2 hypersensitivity, it activates B cell to produce IgM and IgG with help of CD4 and T helper cell. It divides into intrinsic and extrinsic. In non-cytotoxic type 2 hypersensitivity, antibodies bind to the cell, prevent the antigen to bind. This condition block acetylcholine and muscle weakened. This overproduction of thyroid hormone cause hyperthyroidism. For mechanism 1, it involves complement system. C1 binds to the Fc receptor of the antibody and go through enzymatic cascade reaction, forming C3a, C4a, C5a, which is chemotactic factor that attract neutrophils. The neutrophil degranulates enzyme and cause tissue damage. Mechanism 2 also involves complement system. C1 bind to Fc receptor of the antibody and undergo cascade reaction, forming C5b, C6, C7, C8, C9, which forms membrane attack complex, MAC. Membrane attack complex attack by creating a hole on cell membrane and allow fluid to flow into cell and cause cell lysis. Mechanism 3 also involves complement system. C3 bind to Fc receptor of antibody and activate opsonization and phagocytosis. The antigen get engulfed and destroyed by macrophage by binding to the Fc tail of C3b complement. Mechanism 4 is antibody-dependent cell-mediated cytotoxicity, ADCC. Natural killer cell recognize the Fc of IgG and release toxic granules known as perforins, forming pores and granzymes which lead to apoptotic.
Type 3 hypersensitivity is caused by generation of antibody-antigen complex. Generally, immune complex can be formed as antibody bind to soluble antigen deposited on body tissue and lead to damage occur to complement activation, which result in activate complement C5a and C3b, which recruit of neutrophil and macrophage. C5a as a chemoattractant brings in neutrophil and utilize Fc receptor and complement protein to bind to antibody, while C3b as an opsoning attract neutrophil which then release lysosomal enzyme and lead to cell destruction. Arthur's reaction is local immune complex disease. In this reaction, exogenous antigens are delivered locally by subcutaneous injection and rapidly bound by circulating antibody generating immune complex. Serum sickness is a systemic immune complex disease. This disease will cause cryoglobulin precipitate in circulation, blood flow, and capillaries of nose to finger, cause pallor, numbness, and cryognesis. SLE thought to be a disease of preformed immune complex deposition within the glomerulus, which lead to complement activation, immune infiltration, and attendant glomerular damage.
Type 4 hypersensitivity, also known as delay type hypersensitivity, T cell will initiate response instead of antibodies. T cells consist of T helper cells and cytotoxic T cells. Cytotoxic T cells involve CD8 and T cell in MHC class 1, while T helper cells involve CD4 and T cells in MHC class 2. How CD4 and Th1 cell encounter antigen? First, Th1 will secrete cytokine induce localized inflammatory reaction. It will accomplish into two phases, which are sensitization and effector phase. In sensitization phase, primary cells will establish, then T helper cells will sensitize. For the second exposure to the sensitizing antigen, it will induce effector phase.